Students, today we are going to see a new chapter under the title Chapter-wise Instruction for ICSE Class 10 Maths. Today's chapter is going to be Linear Inequation. The next chapter what we take after banking is Linear Inequation. Now what are the important pointers which we need to keep in mind while solving linear inequation problem? So I've just jotted down some important pointers which we all need to keep in mind. The first one, writing solution set is must. Many a times is what students fail to write down the solution set. They directly go with the number line and they fail to write down the solution set. So solution set is very important. Enclose the solution set in curly brackets only. Children, we are not supposed to use round bracket or square bracket for that matter. We are supposed to use only curly bracket. Third, solution set for natural numbers, whole numbers and integers should always be in rooster form or listing method. We all are aware what rooster form and listing method is. So for natural numbers, whole numbers and integers, the solution set should be in rooster form or listing method. Solution set for real numbers should always be in set builder method. For natural, whole and integers, listing method. For real numbers, set builder method. These are the pointers which we need to know while writing down the solution set of linear inequation problem. The next article is very important when it comes to presenting the solution on the number line. Presenting the same solution onto the number line. So how we represent the solution on the number line? So what are the pointers which we need to take care of? Mark arrowhead on both ends of the number line. The very first important instruction is mark arrowhead on both the ends of the number line. Second, write two extra numbers on both the sides of number line. Mind you, there are many teachers who say that we need to write down only one extra number on either side of the number line. Yes, that can be true, but to be on a safer side, having some kind of precautionary measures, we say we write down two extra numbers on both the sides of the number line. Do not use the main important pointer which we all need to take care. Do not use decimal values, example 1.33, 2.66, etc. Use proper fraction or mixed fraction only. Whenever we want to represent a particular number, we are not supposed to present it in decimal form. We are supposed to present in proper fraction form or for that matter mixed fraction form. Let's take 2-3 examples whereby which we understand how the presentation on the number line will look like. The first one, some examples to present solution on the number line. How to represent 1 by 3. When we go for drawing 1 by 3 on a number line, how do we present it? So, the very first thing is, I'm going to draw a number line here. 0 right here. 1, 2. I'll take one more extra, say 3. Here, it's going to be -1, -2. Now, what is the number I need to represent? I need to represent 1 by 3. Now, children, when we divide 1 by 3, the answer turns out to be 0.33. Mind you, we are not supposed to write down 0.33. Neither we are supposed to write down 0.33, nor we are supposed to mark the same. So, 1 by 3 lies between 0 and 1. 1 by 3 lies between 0 and 1. So, with my eye vision, we are not going to go for any kind of scale. With my eye vision, going to divide 0 and 1 into 3 parts. Now the question arises, why we are dividing in 3 parts? Because the denominator over here is by 3. I repeat, 1 by 3 lies between 0 and 1. So the very first thing is what we are going to do is, we are going to divide 0 and 1 into 3 equal parts. First, second and third. This first part, the first one is 0. The next line what you can see is 1 by 3. So I'm going to stretch this line slightly further and I'm going to write down over here 1 by 3. Then many of you have a question, then what is that second one presenting? The second one will present 2 by 3. So let's see how the things work out. This is 0. The very first division is 1 by 3. The second division will be 2 by 3, and the third division will be 3 by 3, and 3 by 3 is eventually 1. 3 by 3 is eventually 1. So the first one number 1 by 3 is presented as, after 0, the first division is 1 by 3. Let's take one more example. How to present 1, 2 by 3. This is a mixed fraction form. This is a mixed fraction form. So how to represent 1, 2 by 3? As our mixed fraction states clearly that the number lies between 1 and 2. The number lies between 1 and 2. So what we are going to do is, we are going to draw once again a number line. Now, center 0. I'll take 1. I shall take 2. One more, 3. Here, -1. Here, -2. Now, 1, 2 by 3. 1, 2 by 3, as we said, our numbers, or 1, 2 by 3 will lie between 1 and 2. So, when I know it lies between 1 and 2, once again I need to divide 1 and 2 into how many equal parts? Yeah, rightly said so. We need to divide into 3 equal parts. Once again, here the denominator is 3. So, we need to divide 1 and 2 into 3 equal parts. So, I'll take 1, I'll take 2. Now, 1, 2 by 3 will be presented as, this is 1. The next division will be 1, 1 by 3. The next division will be 1, 1 by 3. Followed by that is what we are going to have 1, 2 by 3. Followed by that, we are going to have 1, 2 by 3. Now children, as I stated earlier, we need to focus. First, mark arrowhead on both the sides. Did we do so in the previous one and this one? Yes. We are not supposed to use any kind of decimal form? Indeed. Now write 2 extra numbers on both the sides of the number line is what we have noted. Pay very good amount of attention over here. When I say 1, 2 by 3 is what my number is I'm presenting over here, then 2 cannot be stated as my extra number. Mind you, 2 shall not be acting as my extra number. So my first extra number will be 3. So I'll go further to be on a safer side, take one more number and say this is 4. Likewise on the left hand side also, when I say this is 1, 2 by 3, this is 1, 1 by 3. If here, after followed by 1, 2 by 3 is 2, which is not regarded as an extra number, absolutely on the same lines, 1, 2 by 3, and prior to that is 1, 1 by 3, even that is not counted as an extra number. So we have ample of numbers on the left hand side. We are not worried and concerned about on the left hand side. But yes, to be on a safer side, I added one more number, which is number 4. So children, these are the things which we have to be very, very careful while plotting solution set onto the number line. Now let's take an actual example how we solve a linear inequation का sum and we present it on a number line. So after solving an inequation, when we are being given an equation, we solve it by taking all the LCM and shifting the numbers and the variables on one side. Let's see what the final expression. So we are just taking the final answer. 2 less than x less than or equal to x less than 5. Given to me is x is greater than or equal to 2 and less than 5. Or I can say 2 less than or equal to x less than 5 and x belongs to set of natural numbers. So this is what I got an inequality and I need to represent the same thing on the number line. Now there are various ways with many teachers and students follow. Let's look some of them. Let's have a look at some of them. We are once again going to draw a number line. So this is what our number line will be. Now I shall mark 0 on the left hand side. Previously is what I used to mark 0 middle. Why? Because the numbers were that much not far away, so I was just taking 0 at the center. But now when I know that all my numbers are on the positive side and I don't have a negative one, so it's better to take 0 on the left hand side. I take 0 over here, then 1, 2, 3, 4, 5, 6, 7. I'll write down one more over here as -1. Now, let's see what are the numbers. It says that, the inequality says that 2 is less than or equal to x less than 5. x belongs to natural number, so will my x have the number 2? Indeed, yes, rightly said so. I will have 2. I'll put a dark dot on 2. Why I'll have 2? Because it says that x is greater than or equal to 2. Then what values of x can I have? It says that x should be greater than or equal to 2 and it should be less than 5. Moreover, we have to keep in our mind that it belongs to a set of natural numbers. So 2 will be there, 3 will be there, 4 will be there, but 5 won't be there. 2 will be there, 3 will be there, 4 will be there, but 5 won't be there. So we mark down 2, we say 3, we say 4, but we cannot say 5. We cannot say 5. Why? Because x is less than 5. Now I'll just take and alter slightly. We slightly alter within the sum, try to create one more sum. So I'm using a different marker only to make you understand. Had they given me x is less than or equal to 5, mind you this is an extra change we are making and doing it in our sum, then certainly I would have said 5. Certainly I would have stated 5. But if they don't say that x is less than or equal to 5, and if they state the previous condition which I had written earlier, then 5 will not be there in this particular number line. Let's check. If this were to be my question, am I satisfying those conditions which we have studied previously? 2 arrows are there. Yes. Then 2 extra numbers on either side. Mind you, here we have 3. Nothing to worry. We have 2 extra numbers, 6 and 7. So are we satisfying the condition? Indeed, we are satisfying the condition. Let's take one more. What this one says, here solution set is already given to us that we have all the values of x such that x belongs to set of real numbers and 2 less than or equal to x less than 4. Mind you, x belongs to set of real numbers, 2 less than or equal to x less than 4. This is real number, unlike what we had over here, natural number. Here we had natural number, here we have real numbers. So there is a minor change in presenting the solution. Let's see how we present it on the number line. We first go for drawing a number line. Then 0, minus 1, 1, 2, 3, 4, 5, 6. Now they say this solution set where x belongs to real number means I can have all the fractional values, I can have all the decimal values between 2 and 4, but will be exclusive of 4. We cannot include 4 over here. Why? Because x is less than 4. We can include 2, but we are not supposed to include 4 in that. Since it is real number and we are supposed to take all the values between 2 and 4 exclusive 4, so how our graph will look like or the number line will look like? I shall say a very dark dot here on 2. Why? Because x is greater than or equal to 2 and a hollow circle at 4. A dark circle on 2 and a hollow circle on 4. And I shall shade everything in between. This says that my solution set will have all the values of x which will be greater than or equal to 2 but will be less than 4. So 3.999999 will do, but it cannot have 4 within that. Now there are many students who take other way around, and there is one more way of presenting it. So let's see what is the other way around. Both the solutions are very well accepted. Both the solutions are very well accepted. 0, 1, 2, 3, 4, 5, 6. This is one way of presenting. The other way is we have curve and a straight line. We have a curve, a minor curve, a miniature curve though, and a straight line. So we say x is greater than or equal to 2. So we take this as a straight line and x is less than 4, so we take a small curve. We take a small curve innerwards, inside. Inside we take a small curve and we join them. We join them. And shade in between. Now this inside curve says that we have excluded 4. We haven't included 4. And this straight line says that we are supposed to include 2, and that's what we have done. So either we use a dark dot and a hollow circle, that is a dark circle and a hollow circle, or we go for a straight line and a curve. Had they changed the solution, once again, had they changed the solution and they would have given me this is equal to 4, then what I would have done is I would have certainly go for a dark out here and certainly go for a dash here, a complete line here. Mind you, the black color solution is the modified solution which we have made changes. The blue one is the original solution, what was the question. So these are the things which we have to keep in mind while drawing solution set on a number line. Again, the pointers are that have we given arrowheads? Indeed. Have we written down 2 extra numbers? Yes. These are the things is what we have to keep in our mind. Moreover, if there lies any kind of mixed fraction, we need to act as we have studied earlier how to present a mixed fraction. If in case in these sums, if there are mixed fractions, then we know how to present on a number line. We have already learned how to present a mixed fraction and present it on the same number line. Now, in the final part of my session, I shall tell you what are the common mistakes being committed by the students. And these mistakes are in the solution part, not on the number line part. But if their solution goes wrong, eventually their number line will also go wrong. So what are the common mistakes students make it while solving sums on linear equation? Reversal of inequality sign. Students fail to, at times, either they are not aware, but I doubt students are aware, maybe sheer stress or maybe some kind of silly mistakes is what they do so, and they fail to do this particular stuff. So where we need to change the inequality sign, there are 3 pointers is what I'm going to point at, that if you have any one of these, then your inequality sign changes. What are those? If each term is multiplied or for that matter divided by a negative number. So let me take an example. Let me say that 5 is greater than 3. We all are aware 5 is greater than 3. But what if I multiply this 5, or you can say even this 3. That means I'm multiplying the entire inequation. If I multiply this entire inequation by 3, if I multiply this entire inequation by 3, so after, we don't have space, so I'm not writing multiply the inequality by 3. So after multiplying this inequality by 3, 5 3s are 15, 3 3s are 9. Still, I shall say 15 is greater than 9. But now, what if I say that I multiply this inequality, mind you, this inequality, 5 greater than 3, multiplied by minus 3. When I multiply by minus 3, my answer will be minus 15 and minus 9. My children, just tell me which one is bigger according to you. Minus 15 is bigger or minus 9 is bigger? Eventually the answer what you are going to tell me is minus 9 is bigger. So when I multiply the inequality by a negative number, my inequality sign reverses, changes altogether. This did not happen when I multiplied by a positive number. But when I multiplied by a negative number, indeed this happens. Indeed this happens. Likewise, even if you go and divide by a negative number, the same pattern is going to follow. We have to change the inequality sign. Let me say that divide this inequality by minus 2. Divide this inequality by minus 2. So what answer would have got is minus 5 by 2. And here I would have got as minus 3 by 2. Again, we all are aware minus 5 by 2 is minus 2.5. Minus 3 by 2 is minus 1.5. And we all are aware about that. Minus 1.5 is greater than minus 2.5. So what did we learn? We learned that whenever we multiply an inequality or divide an inequality by a negative number, the inequality sign reverses. The next thing, or the next pointer where the sign reverses is while taking the reciprocal on both the sides. So let me continue with the same example, say 1 by 5. Or rather, let me first say with the same one, say 5 is greater than 3. On taking reciprocal of the same, this will turn out to be 1 by 5 and this will turn out to be 1 by 3. This will turn out to be 1 by 5 and that will turn out to be 1 by 3. If we go and check the calculation, 1 by 5 is 0.2 and 1 by 3 is 0.333. Yes, absolutely. So where we need to change it? Yes, it is 1 by 3 is greater than 1 by 5. Earlier it was 5 greater than 3, but by taking reciprocal, the inequality sign had to change and 1 by 5 is less than 1 by 3. The last one, if the sign of each term on both the side of inequation changes. So if earlier it would be minus and if you are changing into plus, or vice versa, it was plus and we are changing into minus. So let me say, we have already seen one with a plus and then going to minus sign. Here what we'll do is we'll take minus and then we say we change the sign on both the side of inequality. What impact we get in the inequality sign? Let's see. Tell me children, out of these two, which one is bigger? Minus 3 is bigger or minus 5 is bigger? As you all are aware and you must have told yourself also, minus 3 is bigger than minus 5. Minus 3 is bigger than minus 5, or you can say minus 5 is less than minus 3. I would like to change the sign of the entire inequality. When I change the sign of this inequality, minus 5 turns to be 5, minus 3 turns to be 3. And now tell me who is bigger? It is 5 bigger than 3. It is 5 bigger than 3. So these are the main pointers where I feel students might go wrong if they do some kind of silly mistake. So the entire yes, more about this one and presenting you shall see in my videos where I have shown you many linear inequations, related sums. We have given n number of sums, taking n number of examples of integers, whole numbers, rational numbers. We have taken real numbers also. You can in detail watch my videos over there also, but this is in general instructions which we need to take when we solve linear inequation sum. We shall see next chapter very soon. Thank you.